Hello and welcome to the class on completely randomized design. A completely randomized design is the one where the treatments are assigned completely at random so that each experimental unit has the same chance of receiving any one treatment. The whole experimental material is divided into a number of experimental units. The experimental units are allotted purely at random to the various treatments. This design imposes no restrictions on the allocation of treatments to the various experimental units. It is preferred when all the experimental material is known to be homogeneous. Any number of experimental units and treatments can be utilized in this particular design. And as the design is highly flexible and simple, it is widely used. Let us try to understand this particular concept with the help of an example. Let us say we have 4 different types of feeds which are to be tested on a breed of cattle for its efficacy in terms of weight gain. The feed will be a factor. 4 different types of feeds will be 4 treatments or 4 levels. For this experiment, let us say we have 24 cattle of the same breed, similar age group, and which are belonging to a particular sex are available. Now, the uniformity of cattle in terms of breed, age, and the sex assures the homogeneous nature of the experimental material. In this experiment, we can divide the available cattle into 4 groups. This is our experimental material and various treatments. Let us randomly allocate our experimental material to the various treatments. Here, the group of 6 cattle is one experimental unit. The respective feed is fed for a specific duration to the cattle in each experimental unit, and the body weight of all the cattle will be recorded at the end of the experiment. This particular design can be plotted in a tabular form, where each dot is representing body weight in kilograms. Now here in CRD, we have seen that the whole experimental material is divided into a number of experimental units. The treatments are assigned completely at random to these experimental units. Each experimental unit has the same chance of receiving any one treatment. Or we can also say that the experimental material is allotted purely at random to the various treatments. This table represents generalized tabular form of a completely randomized design. Let us say we have n number of treatments and each treatment has many observations. These observations are variates which can be designated as Xij, which indicates jth observation of ith treatment, and therefore the equation of CRD will be equal to overall mean plus the effect of ith treatment plus the differences between the observations. In CRD, we can use any number of treatments and replicates, and the statistical analysis of the data is very easy even if some experimental units are missing or rejected. The relative loss of information due to missing data is smaller as compared with any other design. The design is useful in small experiments where the experimental material is limited but homogeneous. This design provides maximum number of degrees of freedom. The main objection in CRD is, however, on the grounds of accuracy. Since there is no restriction on the randomization of the treatments, we cannot be sure that the units receiving one treatment are similar to those receiving the other treatment, and therefore the whole variation among the units enters into experimental error. CRD is advantageous and appropriate where the experimental material is limited in quantity and which is homogeneous. It is also appropriate where it is expected that some of the units will be destroyed or will fail to respond. CRD is advantageous and appropriate in small experiments. Thank you.